Welcome to 5R's Learning Channel, where we review, remember, rediscover, reflect, and relay learning. Today we will— Have you ever walked to school and taken a longer route? Or walked straight to your destination? Did you travel the same distance? Did you reach the same position? Let's find out. Distance is the total path traveled by an object. It tells how far you have gone, regardless of direction. That is why distance is a scalar quantity. On the other hand, displacement is the shortest straight-line path from the starting point to the ending point. It includes both magnitude and direction. That is why displacement is a vector quantity. Let's consider this example. A student walks 12 meters north, then 5 meters south. What is the total distance and displacement? Since distance is a scalar quantity, we disregard direction and simply add the total path traveled. So the distance is 12 meters plus 5 meters equals 17 meters. However, displacement is a vector quantity, so we consider both magnitude and direction. If we take north as positive and south as negative, then the displacement is plus 12 meters minus 5 meters equals plus 7 meters. This means the student's displacement is 7 meters to the north. Second example. A person walks 6 meters east, then 8 meters north. What are the person's distance and displacement? First, let's find the distance. Since distance is a scalar quantity, we simply add the total path traveled. 6 meters plus 8 meters equals 14 meters. For the displacement, we need to determine the shortest straight-line path using the Pythagorean Theorem. C equals square root of a squared plus b squared. Substituting the values, c equals square root of 6 squared plus 8 squared. So we have square root of 36 plus 64, which is equal to the square root of 100, which is 10 meters. To calculate for the direction, we'll use arctan of 8 over 6, which is approximately 53 degrees. Therefore, the displacement is 10 meters at 53 degrees north of east. Let's solve another example. A person walks 9 meters east, then 12 meters north. First, let's find the distance. Since distance is a scalar quantity, we simply add the total path traveled. So 9 meters plus 12 meters equals 21 meters. The distance is 21 meters. Now let's find the displacement. We need to determine the shortest straight-line path from the starting point to the ending point. We use the Pythagorean Theorem. C equals the square root of a squared plus b squared. Substituting the values, we have square root of 81 plus 144, which is equal to the square root of 225. So the displacement is 15 meters. To find the direction, we use the inverse tangent function. Theta equals arctangent of 12 over 9. This is approximately 53 degrees. Therefore, the displacement is 15 meters at 53 degrees north of east. Now, let's reflect. Distance shows how far we travel, but displacement shows where we end up. In your daily life, you may go through many activities: school, home, friends, and challenges. Sometimes you take longer paths, make mistakes, or try different ways. But what matters most is your direction and your goal. Just like displacement, what matters is where you are heading. So always choose the right direction toward your goals, your growth, and becoming a better person. Now let's check your understanding. There are 8 questions. You may pause the video after each question. 1. What is distance? 2. What is displacement? 3. What is the main difference between distance and displacement? 4. A student walks 10 meters north, then stops. What is the distance and displacement? 5. A student walks 25 meters east, then 15 meters west. What is the total distance? What is the displacement? 6. A student walks 10 meters south, then 10 meters north. What is the distance? What is the displacement? Explain why. 7. A person walks 6 meters east, then 8 meters north. Find the distance, then calculate the displacement. 8. A student walks 12 meters east, 5 meters west, and then 3 meters east. What is the total distance? What is the displacement? Explain your answer. Thank you for learning with 5R's Learning Channel. Don't forget to like, share, and subscribe. See you in our next lesson.